Hi guys, this is Kinetics 107 and we're talking about factors affecting rates. So different aspects of reactions that can affect the rate of the reaction. So your homework is just to take notes, and I just want to start with this idea of collision theory quotes, and that is in order to react, molecules must collide. So molecules have to come together and hit each other in order for a reaction to take place. And there's two components to the reaction. So they have to collide with enough energy. And we're going to be specific here and say kinetic energy. And they have to collide with the proper orientation. So let me just translate that over here. They have to be going fast enough. And then with the proper orientation, they have to be facing the right direction. So that their electrons are either exposed or they're not exposed, and they have to be going fast enough to overcome something called activation energy. So we're going to talk about that in just a minute. Okay, so some factors that can affect the speeds of reactions. Okay, so the first factor, as you may have guessed, is temperature. And temperature is just the heat energy that gives something a temperature, or temperature is a measure of the kinetic energy of a molecule. Measure of kinetic energy. So kind of a measure of how fast the molecules are moving. So we want to remember that as temperature goes up, molecules move faster. So their speed goes up. So as you would expect, there are more collisions. So we'll say collision frequency goes up. Therefore, the rate of the reaction also goes up. So that's kind of a bunch of therefore statements, but as temperature goes up, molecules move faster, and that's just in parentheses there, speed increases. So collision frequency goes up, therefore the rate of reaction goes up. So the more collisions there are, the more likely there is that there's a collision that will result in a reaction. So that's our first item that can affect rates. Okay, so the second one, pink in pink, and that is the concentration of the reactants. And as you would expect, as the concentration of the reactants goes up, again, collision frequency also goes up. Therefore, rate of reaction goes up. And again, it just all comes down to what's the frequency of the collisions. Okay, and number 3, we're gonna have 5 total. So number 3 is activation energy. And this is symbolized with capital E sub A. And this is just the minimum amount of energy needed to get a reaction started. So as you may expect, as activation energy goes up, reaction rate goes down because you need more energy to achieve the reaction getting started. It's kind of like getting over a hill and then going down a hill, and we'll talk more about that when we do energy diagrams. Okay, and number 4 is the presence of a catalyst. And a catalyst is a molecule that binds to a reactant. So it is in proper orientation for a reaction to occur. So as you may guess, when a catalyst is present, the rate of reaction goes up, and the reason that occurs is because the reactant is in proper orientation, and because the reactant's in proper orientation, the activation energy actually is decreased. So if the right part of the molecule is exposed, there's less activation energy needed, less kinetic energy needed for the reaction to go forward. Okay, and the last but not least is the states of matter of the reactants. And you want to think along the lines of the relative kinetic energies of the different states. So we know for these guys that gases have greater kinetic energy than do liquids, and liquids have greater kinetic energy than solids. So we want to keep in mind that gases will always have faster, gas reactants will react faster than liquids, and then also will react faster than solids as well, and then liquids will react faster than solids. And the other thing you want to remember is that surface area can make a difference too. Surface area of solids affects rate. And that is with more surface area. Oopsie. You guys see that? Dang it. I'm totally off the screen. With more surface area, the reaction rate will go up. So if you think of like a fine powder of a reactant versus a large block of the reactant, the fine powder will react faster. Sorry, that's totally squished. So the fine powder will react faster than something that's just in a large block of solid. Okay, so those are factors affecting rates. Thank you.